Good morning everyone, my name is Daniel HAZIQ bin SANUDDIN. Today I'll be presenting about electricity and magnetism, one of the most important topics in physical science. We will explore how electric and magnetic effects are described using vector and mathematical tools. Here's the agenda for today. We will start with vector analysis, followed by coordinate system, then vector calculus, and finally we'll look into static electric field. For vector analysis, vector is a quantity that has both magnitude and direction. For example, displacement, velocity, and force. Scalar is a quantity that has only magnitude, such as charge, time, mass, and energy. For magnitude of vector, we used to find magnitude of A for further calculation that can be used to find vector. So this is the formula that we use. And unit vector only show the direction of a vector. It has magnitude and direction. For vector addition and subtraction, it carry out component by component. Two vectors A and B can be added together to give another vector C. For example, given two vector point A and B, as we can see here. Next is dot product. Dot product written as A dot B and result in scalar product. For cross product, it written as A cross B. Vector multiplication is called cross product and the result in vector product. Okay, we move on to next topic, which is coordinate system and transformation. So the first one is Cartesian coordinate. Cartesian coordinate, also known as a rectangular, it contains of variable x, y, and z. Coordinate system is written as ax, ay, az. The value of x, y, z can be negative infinity until infinity. Next is cylindrical coordinate. It contains of variable rho, phi, and z. The coordinate is written as a rho, a phi, a z. The value of rho can be 0 until infinity. Value of phi 0 until 2 pi, and the value of z negative infinity until infinity. Next one is spherical coordinate. It contains of variable r, theta, and phi. The coordinate is written as ar, a theta, a phi. The value of r is 0 until infinity. Value of theta 0 until pi. The value of phi 0 until 2 pi. This is the coordinate transformation. We can change from one coordinate system to another. This helps us when we solve problem with different shape like sphere or cylindrical. So we can change coordinate system from Cartesian to cylindrical and Cartesian to spherical, spherical to Cartesian. We can use this formula for point coordinates and vector component. We move on to the next topic, which is vector calculus. So there's many of topic that include here, which is differential displacement, differential normal surface, differential volume, del operator, gradient of scalar, divergence of vector, curl of a vector, and Laplacian of scalar. So we use all this formula for Cartesian coordinate, cylindrical coordinate, spherical coordinate to solve our calculation. Okay, now we move on to the next topic, which is the last topic, which is static electric field. In this topic, we will learn about Coulomb's law. Coulomb's law states that the force between 2 point charge Q1 and Q2 is along the line joining them. directly proportional to the product Q1, Q2 of the charge, and inversely proportional to the square of the distance r between them. This is the formula that we use, which is F equals to K Q1 Q2 over R square, and we replace the K with 1 over 4 pi epsilon naught. Then we got the formula F equals to Q1 Q2 over 4 pi epsilon naught R square. Force due to multiple point charge. In summation form, we use the formula force equals to Q over 4 pi epsilon naught sum of QK bracket R minus R over R minus RK power of 3. Next, electric field. The electric field intensity or electric field strength E is the force per unit charge when placed in the electric field. So this is the formula that we will use, which is E equals to F over Q. Then we replace the force that we learned before, F and over Q, and we got the formula is E over Q. E equals to Q bracket R minus R over 4 pi epsilon naught R minus R dot times with 3. So we move on to linear surface and volume charge density. For linear charge density, the amount of charge per unit length. It is used when trying to determine the electric field created by a charge rod. Next is surface charge density, the amount of charge per unit area. It is used when determine the electric field above a charge sheet or disk. Last, volume charge density, the amount of charge per unit volume. It is used when determining the electric field due to a uniformly charged sphere made of insulating material. So this is the formula that we will use for differential element: line charge TL, surface charge TS, volume charge dV. The charge density rho L, rho S, rho V. The amount of charge in an element: dq rho L dL, dq rho S ds, dq rho V dV. The last one is the charge distribution. For line charge, Q is to integrate L rho L dL, Q equals to integrate S rho S ds, Q equals to integrate V rho V dV. Next, the electric field due to distribute charge. For line charge, we use the E equals to integrate rho L dL over 4 pi epsilon naught R square unit vector. For surface charge, E equals to integrate rho S ds over 4 pi epsilon naught R square times with unit vector. Volume charge, E equals to integrate rho V dV over 4 pi epsilon naught R square times with AR unit vector. So this is the formula that we will use for line charge, surface charge, and volume charge. For charge element, electric field due to charge element, electric field at point P. Okay, the next one is electric flux density, which is D equals to epsilon naught E. So if D due to point charge, the formula is D equals to Q over 4 pi R square unit vector. Due to line charge, D is equals to rho L over 2 pi P unit vector. D due to infinite sheet of charge, D is equals to rho S over 2 unit vector. And last one, D due to volume charge, which is D equals to integrate rho V dV over 4 pi R square unit vector. The next one we will learn about Gauss law. Gauss law states that the total electric flux through any closed surface is equal to the total charge enclosed by that surface. As we can see here, mathematically, electric flux equals to total charge will result, which is rho v equals to the first Maxwell equation. So the divergence of electric flux density is the volume charge density, which is the first Maxwell equation. The last one, electric potential. The work dW, that is the potential energy required to move charge Q by a displacement dl in an electric field E, is dW equals to negative F dl or equals to negative QE dl. The formula for the total work done here and potential energy per unit charge here, as we can see. So we will use this formula to calculate the electric field, the potential difference, and the potential due to a point charge. That's all from me. Thank you very much.